operates.
But not just that, I'm also going to show you how you can test it
Using nothing but a basic multimeter.
Alright, so the job of your oxygen sensor is to measure the number of oxygen molecules that are coming from your engine into your exhaust.
And then measure the difference between the oxygen molecules in your exhaust and the oxygen molecules that are normally in the atmosphere.
See these tiny holes? This is where it takes in the air that's in the atmosphere.
Next, by using the sensing element that's in your oxygen sensor, it turns that difference into a voltage. Now the range of voltage you're going to get out of your oxygen sensor is going to be 0 to 1 volts. But in practice, it's actually going to be 0.1 to 0.9 volts. Now, the greater the difference between the oxygen molecules coming out of your engine compared to the oxygen molecules in the atmosphere, the larger the voltage is going to be. And this larger voltage is going to translate into a rich condition to your PCM. Now, a rich condition means basically you have too much fuel to oxygen or air that's in your exhaust. And on the other hand, if you get a lower voltage, it's going to mean a lean condition. And a lean condition means you have too little fuel to too much air in your exhaust. So from this voltage that your car's computer receives from your O2 sensor, it tries to correct the air-fuel mixture. Now on a 4-cylinder engine like this, you're going to have two O2 sensors. The first one is going to be your pre-cat or upstream sensor. This is a sensor that comes before your catalytic converter. And the second one is going to be your post-cat or downstream O2 sensor. So if you have a check engine light and a fault code on a car like this would be bank 1 sensor 1 malfunction, and that would be bank 1 sensor 2 malfunction, since there's only one bank on this engine. But what if you have a V6 or a V8 engine like we got here? If that's the case, the bank that has cylinder number 1 in it is going to be your bank 1, the other side is going to be your bank 2. Now if you can't find cylinder number 1 for whatever reason, here's a quick tip that will help you find it. Cylinder number 1 is going to be always the one that's closest to your timing chain or timing belt. And if you were to look at your engine from the side, you can quickly find out which one is closer. In our case, it's going to be this one. So this is going to be our bank 1. So the first O2 sensor from that side is going to be your bank 1 sensor 1. Past your catalytic converter is going to be your bank 1 sensor 2. From this one is going to be bank 2 sensor 1. And then from there, bank 2 sensor 2. And this brings us to the purpose of your post-cat oxygen sensor. See, the post-cat oxygen sensor, generally speaking, is just there to monitor the efficiency of your catalytic converter. And if you have a good working catalytic converter and a good working oxygen sensor, you should pretty much just see a steady reading of 0.5 volts. Or something around that, I should say, but it should remain steady. So with that out of the way, let's talk about the different types of oxygen sensors out there. And we will start from the beginning, the one-wire oxygen sensor. And these sensors, that one wire is going to be your signal wire. This is the wire that sends the voltage signal from your sensor to your car's computer. And this sensor receives its ground by being screwed into the exhaust manifold. And your exhaust manifold gets its ground by being attached to your car's engine. And your car's engine is grounded by this cable attaching it to your chassis. And your chassis is grounded by this cable from your negative post on your battery that's bolted into the chassis. So as you can see on these circuits, the ground side can fail on about 7 different points. So next in the evolution of oxygen sensors was the 2-wire oxygen sensor. Given your oxygen sensor its own ground wire directly to the PCM. Now the sensing element in these sensors doesn't reach operating temperature until it reaches about 600 degrees Fahrenheit, I believe. And that can take a while, and if your car's computer doesn't have a signal from your oxygen sensor, it's not going to run very efficient, and it's going to negatively affect your MPG. So car manufacturers, in order to heat these up faster, decided to add a little heating circuit into these sensors. And these sensors with heating circuits came either with 3 wires or 4 wires. The 3-wire oxygen sensor receives constant voltage from your car's fuse box or junction box, and it's switched on and off by the ground wire, which is connected to your car's PCM. The sensor has a signal wire, but it doesn't have a ground wire for the sensing element. It is grounded again through the exhaust manifold. Now on the 4-wire oxygen sensor, as one would expect, the sensing element has its own signal and ground wires, and the heating element has its ground wire, which is switched on and off by your car's PCM, and again its own voltage supply wire. Now as far as how you can test these sensors, it's pretty easy. All you need is a basic multimeter. So first we'll test the heating circuit in this sensor. And the 2 wires for the heating circuit are usually the same color, usually either white or black or sometimes gray. And we're going to do a resistance check of this sensor. So we grab our multimeter, put it on the ohm setting, and we're going to choose 200. Now the reading we expect to see is obviously going to be different from sensor to sensor, but it's usually not that high. And as you can see, we got about 9.7 ohms, which I believe to be spec for the sensor. So if you do this test and the readings are not within spec, you can just go ahead and toss your oxygen sensor. There's no need to go any further. Now if you have a check engine light and the code is for a heating circuit of an O2 sensor, either short or open, and you do the resistance check on the heating circuit and it checks out, then it's time to check the wiring on the wiring harness that is coming from your car's PCM and the junction box. So what you want to do is to grab yourself a test light, and then you want to find the wiring harness for the said O2 sensor. Now I don't have an O2 sensor here with 4 wires. This is obviously a 1-wire sensor that's connected to this car, but I'm talking about the connector that's on the harness side, not the connector for the O2 sensor side. So you would remove this, and then you want to get in your car and start it. You just want to make sure that your car has been sitting for a while and it's cold, because otherwise your car's computer might not command the heating circuit on for your oxygen sensor. Okay, so you get in your car, you start it from a cold start, and then you get your test light. You attach this side to battery ground, then you probe these 2 sensors on the harness side, and one of them should give you 12 volts, or in other words, light up your test light. If you don't get 12 volts, then you want to check this fuse in your fuse box. If that's good, then you might have a problem in this wiring that's coming from your fuse box. So if that checks out, you want to switch this side from your battery negative to battery positive, and then probe the ground wire that's going to the heating circuit in your oxygen sensor. If your test light lights up, then that's fine as well. If it doesn't, then you want to check this wire that's coming from your PCM, or highly unlikely scenario, it could be a problem with your PCM. Alright, so if the heating circuit checks out, or if you have a check engine light for the signal that's coming from your O2 sensor, next it's time to see whether this O2 sensor is capable of putting out voltage or not. So what you want to do next is to identify the 2 corresponding wire on the harness side that are for sensor signal and sensor ground, and then back probe these with your multimeter probes. And you want to set your multimeter to 2 volts on the DC voltage scale. Alright, so again on this car, since the sensor has only 1 wire, I got my red test lead connected to the sensor, and I couldn't get a good back probe into the harness side, so I just connected directly to the connector for the sensor. But you try to back probe this harness side this way, you check the integrity of this connection as well. And then I have my ground wire connected to battery negative. So next we're going to get in the car and start it, and then if it's from a cold start, we're going to wait about 15 minutes to make sure that the car has reached operating temperature before we observe the reading on our multimeter. Alright, so it's been about 15 minutes with the car running, so let's go check our reading. Now before we do that though, on a good O2 sensor, on an engine that's working properly, the reading should be oscillating between 0.1 to 0.9 volts. And basically should be going up and down. This is on the pre-CAT O2 sensor. But if you're measuring the post-CAT O2 sensor, the reading for that should be staying steady at 0.5 volts if your catalytic converter is working properly. So here's our reading on this pre-CAT O2 sensor. As you can see, we got about 0.07 volts, which is way below 0.1 volts, and it's not even oscillating. It's not even going up and down. It's just staying steady at about 0.07 volts. Now before we condemn the O2 sensor though, we need to make sure that it's actually the O2 sensor and it's not the car that's running very, very lean. So what I'm going to first try is to rev the engine by opening the throttle, see if that changes the reading on this O2 sensor. In other words, see whether this O2 sensor is capable of reading higher voltage than this. So there, just as you saw, this sensor is capable of reading higher voltage, but it's not for whatever reason at idle. So that means this engine could be running lean. But actually, in the case of this car, I believe it to be a leaking exhaust manifold gasket. So that leak in the exhaust manifold gasket is introducing air from the atmosphere into the exhaust system, lowering the difference in the oxygen molecules in the exhaust system and the outside atmosphere. And that's going to translate into a low voltage reading, as you can see here. Now another way to richen the air-fuel mixture and see whether your O2 sensor responds or not is to use some propane. You simply pull off a vacuum line and then start adding propane into the intake manifold. Now on the other hand, if this number was stuck way up, let's say about 0.8 volts, and it wasn't coming down or oscillating, and you wanted to see whether it was a sensor that was bad or there was a car that was running rich, all you would have to do is to pull off a vacuum line, introducing air into the intake manifold, and then observing the numbers. And these numbers would have to decrease if you have a working O2 sensor. Now if you test your O2 sensor and it's putting out voltage and it's also oscillating, in other words it looks to be working properly, then you might have a short or a problem in the wires that go to it, either the ground wire or the signal wire. The way you can check the ground wire is to get your test light, put this side on the battery positive, put this on the ground wire on the harness side. If your test light lights up, then the ground is fine. And then if the way to check the signal wire is, this is a little bit more tricky. You know, you keep this end on the battery positive and then use your test light to introduce voltage to this signal wire. But then again, to see whether you're getting voltage at the PCM, you need to find your PCM, find the correct pin for this wire, and use your multimeter to read the voltage at the PCM. A much easier, obviously, way to do this would be to use a scanner capable of reading live data. You know, you do the same thing with the test light, introducing voltage to this wire, and then you would get the scanner, get the reading for that sensor, see what kind of voltage it's getting from the sensor. If the voltage goes up when you put this on the signal wire, then that means that you know, the signal wire is probably in good shape and your problem lies somewhere else. Now before you start pulling out PCMs and working too hard, you got to keep in mind that these wires that go to these O2 sensors are really close to the engine or the exhaust manifold or exhaust pipes, and these are obviously very hot components, and they could burn these wires, burn through the insulation and damage these wires. So you want to make sure you do a very close inspection of these wires before you you know, get in too deep. And that's all there is to it, folks. Hope that wasn't too much information and didn't confuse the hell out of you. If you didn't, do me a favor and share this video on your favorite social network, or join me there. I'll put a link to my pages in the description box down below. You may also want to consider checking out some of these other related videos, of which I'll put links to on this side of the screen that you can click on. There'll also be links in the description box down below. Alright, thanks for watching. I'll see you guys next time.